What's up, guys? It's Kayla.
And Jim.
Welcome back to another Meteorology Monday. What are we talking about today?
Today we are going to discuss a newer technology introduced to NOAA, and that is Saildrones. Now, we actually touched upon them briefly in one of our hurricane videos a while back, but today we'll get into a more in-depth look of Saildrones, how they actually work, and what benefits they bring to the weather community and the general public.
Here is your bi-monthly tech video in the Meteotech weather realm of things.
But before we get started,
If you find that you were enjoying this video along the way, be sure to leave a like and subscribe down below so you never miss the next Meteorology Monday.
so let's get into Saildrones. First, what are Saildrones?
Well, as you can imagine, there are parts of the ocean that we can't physically get to all the time in manned vessels. So Saildrones are unmanned vessels that are powered by solar power, wind power, and they get to more remote areas of the Earth that might be difficult for us to explore with actual people. They're also extremely useful in conditions such as hurricanes, where maybe you don't want to sail a boat into the middle of a hurricane. So we have these Saildrones that can go into harsh weather environments like that and collect vital data that helps us with some things that we'll talk about here at the end.
And as of September 2024, they can actually run up to about 12 months going out on whatever activity they need to do without having maintenance or having to come back to land. That's another benefit as well.
So what you're saying is it's not like one of those remote controlled little armada things that you have. You go to the lake and you put your little boat there and you got your remote control and you sail them around like a little buoy out there?
Sort of.
Okay.
But we'll get to that. In October 2013, a Saildrone nicknamed Honey Badger completed the first no-handed Pacific crossing, sailing 2,248 nautical miles in 34 days from San Francisco to Hawaii. So these days they actually have numbers associated with them and not necessarily names, but back then they named them. Although Saildrones have evolved over time, the latest Explorer design, according to Saildrone.com, is a 23-foot hull and has a deeper, heavier keel. They are powered by a 15-foot wing, which is effectively a sail like on a sailboat, but of a design more similar to the wing of an airplane. Wind passing over the wing produces thrust, and a small tab on the end of the tail attached to the wing controls the angle of attack. The rudder controls the direction of the hull, and the keel keeps the Saildrone upright. The Saildrone Explorer is used primarily for science data collection and single-beam ocean mapping.
There are also larger Saildrones that are more specifically designed for maritime security, ocean mapping, and deep ocean multi-beam mapping.
Saildrones are equipped with GPS and an onboard computer, enabling the vehicles to navigate following prescribed waypoints, while staying in a safety corridor, taking winds and currents into consideration autonomously. All vehicles are supervised 24/7 by trained operators at the Saildrone Mission Control in Alameda, California. Alright, so going back to what you said earlier about having remote controls and navigating them around the pond, yes, technically they do. They just have a much bigger facility to do it from.
And I don't think that they race them for entertainment.
Not yet, but you never know what they might do. So now that we know how they're made, let's dive into what kind of data they collect.
Each Saildrone carries a payload of science-grade sensors to measure important atmospheric and oceanographic environmental variables in real time, map the seafloor in high resolution, and provide persistent maritime domain awareness. They have been deployed on data collection missions in the Arctic, Atlantic, North Sea, Tropical Pacific, South Pacific, Southern Ocean, Gulf of Mexico, and along the North American west coast to track fish and mammals, measure how much carbon is being absorbed by the ocean, study why some hurricanes intensify so rapidly, and even stand in for disabled weather buoys. So how do these Saildrones compare to the traditional weather buoys that are already out in the ocean?
While ocean buoys are expensive and difficult to deploy and maintain, Saildrone Explorers fit in a shipping container, can be deployed from any oceanside dock, and will return to the same dock without requiring a ship. Routes can be altered on the fly by scientists via the online Saildrone mission portal. To ensure safe operations at sea, each Saildrone carries an automated identification system, AIS, transceiver, enabling it to see and be seen by surrounding commercial traffic. The vehicles are slow relative to other marine users and are designed to be highly visible. They are designed with high visibility colors for daytime visibility and a bright navigation light for nighttime awareness. And the larger Voyager and Surveyor class vehicles are equipped with a radar reflector. Onboard cameras provide domain awareness to operators at Saildrone Mission Control. In summary, a Saildrone can reduce operating costs, enable monitoring of much larger areas in real time, and help us understand how ocean systems work without putting human lives at risk in dangerous conditions. So, how do they benefit us in relation to weather?
Now, there are a lot of cases that Saildrones can be used in, such as transatlantic cabling, homeland security, fisheries, other oceany type things, but specifically for weather and climate, there's a decent list for which we use Saildrones.
That's right. Obviously, we talked about one of them being hurricanes.
That is right.
You know, going into especially very strong hurricanes.
Yes.
Now, you're familiar with the C-130 aircraft and other NOAA aircraft going into a hurricane, but there's never been anything at the surface. And so by using this technology, you can actually get surface reports within the hurricane. So that's one example.
Yeah, it's really helpful when a hurricane hits a weather buoy and we can get that, bottom level weather observation, but I mean the likelihood of a hurricane always hitting a weather buoy isn't phenomenal, so to have something that you can put directly in the path, kind of like a tornado probe, in the path of these hurricanes is super helpful.
Another one would be exploring, let's say, the perimeter of Antarctica.
Yeah.
There's harsh weather conditions down at that latitude. Another good example of using Saildrones to collect scientific information. So we've already talked about that they can be out at sea for up to 12 months at a time as of September 2024. Also, they have a lot of high quality instrumentation so they can get very, very good data quality from what they are recording. But one of the other things is that they can do multiple missions at once. So let's say you have a very active hurricane season and unfortunately you only have a limited amount of planes that can go into these systems, whereas with Saildrones you can actually send multiple Saildrones out to different locations without having the crew for one or two planes having to try to go across vast expanses of the ocean to try to get from one storm to the other. And going back to one more thing, and that is that they are driven by solar and wind energy, so it does provide a low carbon footprint when it comes to the environment. A lot of good positives here.
Yeah.
How about we take a look at a couple of specific examples when it comes to weather?
And a great example of that is Hurricane Sam. On September 30th, 2021, a Saildrone uncrewed surface vehicle made history by intercepting the eye wall of Hurricane Sam in the northwestern tropical Atlantic, recording a viral video of what it's like to be tossed around by 100-mile-per-hour winds and 30-foot high waves. The Guinness Book of World Records later certified that a 126.4 mile-per-hour wind gust recorded by the bright orange 23-foot Saildrone in the core of the Category 4 storm was a new world record for an uncrewed surface vehicle. This Saildrone was able to take continuous readings during the storm, and researchers can use this data to update weather forecast models. One model in particular that could significantly benefit from this is the hurricane models that forecast a hurricane's intensity. Sam turned out to be one of the longest and strongest hurricanes in our historical record. We were targeting the northeast eye wall and the intercept was a bullseye. Until now, we haven't had a surface platform that we can steer into a hurricane while it continuously measures air-sea interactions and transmits data in near real time for use by numerical hurricane forecast models. Early and accurate forecasts of storm tracks and intensity are vital for protecting life and property from hurricane impacts. During the past decade, however, the accuracy of hurricane track prediction has substantially outpaced those for storm intensity, which is influenced by transfers of heat and momentum across the ocean surface during tropical cyclone development. sea surface temperatures has long been used as a statistical predictor of intensity. Analysis by the research team found the observations and measurements collected by the ocean robot revealed surface ocean temperatures had unexpectedly risen during the first half of the storm. These changes were not captured by satellites, profiling floats, or hurricane hunting aircrafts that provide the data used by hurricane forecast models. As a result, the forecast model predicted surface waters to be cooler than they actually were. This caused the model to underestimate the flow of heat from the ocean into the storm near the eye wall, which reduced the forecast potential intensity of the storm. Researchers are also exploring adding new sensors to future Saildrone missions to capture unique measurements like sea spray, which influences heat and momentum exchanges within hurricanes. What's another example that Saildrones are useful for in weather and climate?
Well, let's see. If we're talking about oceans, how about the El Nino-La Nina effect?
Of course.
So how about introducing Saildrones into that as well to gain a better understanding of what's going on? El Nino and La Nina impact weather patterns and climate around the world and lead to events such as coastal flooding, droughts, and wildfires, and shifting fish marine life, which impacts fisheries and the larger oceanic ecosystem. The Tropical Pacific Observation System was developed to monitor oceanographic and meteorological conditions in the region to improve early predictions of major weather events like El Nino and La Nina. The network combines a variety of observation platforms including ship-based surveys, satellites, and a grid of buoys moored to the bottom of the Pacific Ocean to provide the data required to understand environmental phenomena and develop essential global weather forecasts. The TPOS 2020 project was initiated by the National Oceanic and Atmospheric Administration, NOAA, and 13 science organizations from 6 countries to redesign the Tropical Pacific Observing System by the year 2020. The cost and complications of maintaining the existing system prompted NOAA and its partners to look for a new tool to maintain and ultimately improve the quality of data. In September 2017, Saildrone partnered with NOAA to launch a series of 6-month missions to the tropical Pacific to test how unmanned surface vehicles could augment TPOS data collection and improve long-term weather forecasting. During the first mission, Saildrone's SD-1005 and SD-1006 were used to validate collected measurements by the existing systems. Their initial findings showed sea surface temperature shifts that were previously undetectable by satellite or buoys. Over the past several years, Saildrones have been deployed from San Francisco and Hawaii to survey near the equator and from Guam to collect data in the western equatorial Pacific and collect surface ocean and meteorological measurements in the Kuroshio Surface Current, a western boundary current similar to the Gulf Stream in the Atlantic Ocean.
So there you have it, Saildrones. Hopefully this video gives you a good understanding about what Saildrones are and how we use them to benefit both meteorology and climatology.
As well as non-meteorological applications as well.
That's right. Again, if you like what you saw, be sure to leave a like and subscribe down below so you never miss the next one. As always, check out our weather adventures on Facebook and Instagram popping up here, as well as checking out our School of Weather if you want to listen to us talk about basics of meteorology, getting into some severe weather things like how tornadoes and hurricanes form, which is pretty relevant to this video. Check it out, it'll be the first link in the description box. Until next time, I'm Kayla.
And I'm Jim.
Thanks for watching.
And we'll see you at the next Meteorology Monday.